Hello friends, today we are going to solve question number 56 from GATE 2022. So this is a linear algebra question. We are given R3 as a vector space with usual operations of vector addition and scalar multiplication. And let X belongs to R3 be a vector denoted by this. And two subspaces are defined, W1 and W2. By W1 is equal to X belongs to R3 such that X1 plus twice X2 minus X3 is equal to 0, and W2 is X belongs to R3 such that twice X1 plus thrice X3 is equal to 0, and dimension of U denote the dimension of the subspace U. Then we have to find out which of the following statements are true. So this is a multiple select question. It means that more than one option can be true. So we have to find out exactly which statements are true. So let's get started on this. So first option is dimension of W1 is equal to dimension of W2. So let's find out dimension of both the vector subspaces first. Now W1 is equal to X belongs to R3 such that X1 plus twice X2 minus X3 is equal to 0. Right. Now let X belongs to W1. This implies X1 plus twice X2 minus X3 is equal to 0. So this implies we can write X1 as scalar sum of X2 and X3. Right. So if we assume X2 and X3 as free variables, then we can write X1 in terms of X2 and X3, right? So this implies X is equal to X1, X2, X3, which is equal to, what is X1? It's twice X2 plus X3. Second coordinate X2 and third X3. So we can write this as twice X2, X2, 0 plus X3, 0, X3, right? So it means if we take X2 common from first term, we are left with minus 2, 1, 0 plus X3 into 1, 0, 1. Right. Thus, W1 is nothing but span of these two vectors. Right. And as we can see, these two vectors are linearly independent as well because they're not scalar multiple of each other. So this means that these two vectors forms a basis for W1. Therefore, dimension of W1 is 2. Now we have got dimension of W2. Now let's find out dimension of dimension of W1 is 2. So now let's find out dimension of W2. Now W2 is defined as X belongs to R3 such that X twice X1 plus thrice X3 is equal to 0. So to find out dimension of W2, let X belongs to W2. This implies twice X1 plus thrice X3 is equal to 0. So this implies X1 is equal to minus 3 by 2 X3, and we do not have any restriction of second coordinate X2, right? So we can treat it as a free variable, and we can treat X3 as a free variable because we have X1 in terms of X3. So this implies X is equal to X1, X2, X3, which is equal to minus 3 by 2 X3, comma X2, comma X3, right? So we can write this as minus 3 by 2 X3, 0 X3 plus 0 X2, 0. Right, so this is nothing but X3 into minus 3 by 2, 0, 1 plus X2 into 0, 1, 0. So this means that W2 is a span of these two vectors, right? Also, these two vectors are linearly independent. So this means that these two vectors form a basis for W2. Therefore, dimension of W2 is also 2. Thus, we have dimension of W1 and dimension of W2 is equal. Therefore, option A is true here. Right? So let's check with option B. Now, the left hand side will be for B part. LHS is equal to dimension of W1 is 2 plus dimension of W2 is also 2 minus dimension of R3 is 3, which is equal to 2 plus 2 4, 4 minus 3 1. Right? So it is equal to RHS. Therefore option B is also true. Okay, now for C part. Okay, now we have one formula that dimension of W1 plus W2 is equal to dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. Right. So if we know, it is easier to find dimension of W1 intersection W2 than finding this, right? So if we find out this first, then we can easily know this because we already know W1 dimensions of W1 and W2. And anyway, we have to find dimension of W1 intersection W2 because for option D, we need that. So let's first find out dimension of W1 intersection W2. So for that, let X belongs to W1 intersection W2. So this implies X belongs to W1 means we have a condition which is X1, this condition, right? X1 plus 2x2 minus x3 is equal to 0. And X belongs to W2 means twice X1 plus 3x3 is equal to 0, right? Yes. So from these two equations, we have to find dimension of W1 intersection W2. So from this first, we have, okay, let's look at this first. From this, we can write x1 is equal to minus 3 by 2 x3. So put value of x1 in this equation, we get minus 3 by 2 x3 plus twice x2 minus x3 is equal to 0. So from this, we can write x2 as 3 by 2 minus 3 by 2 minus 1 is minus 5 by 2. So on, if it comes to the other side, it will be 5 by 2 x3 and this 2, right? Yes, so this is 5 by 4 x3. Thus we have x is equal to x1 x2 x3, which is equal to x1 is this minus 3 by 2 x3, x2 is 5 by 4 x3 comma x3, right? So if we take x3 common, then we are left with 3 by 2 comma 5 by 4 comma 1, right? Thus any vector which is in W1 intersection W2, it can be written as this. So this means that W1 intersection W2 is span of this vector. It means that this is the dimension of W1 intersection W2, that is, it is 1 because it is spanned by one vector, which is non-zero, of course. Therefore dimension of W1 intersection W2 is equal to 1, right? So I believe this is D option. Yes, so option D is also correct. Okay, now for option C, we'll use this formula. Now dimension of W1 is 2, dimension of W2 is also 2, and dimension of W1 intersection W2 is 1, as we found out just now. So this is 2 plus 2, 4. 4 minus 1, 3. So this is 3. So it doesn't match with option C because we are given dimension of W1 plus W2 as 2. So this option is not correct, right? Thus only options A, B and D are correct. So the solution is A, B, D. Okay, so I hope you all understood this question well. See you in the next video. Thank you.